Greetings, today I would like to show you a solution of a recursive equation. Recursive equations, they usually Greetings, today I would like to show you a solution of a recursive equation. X equals square root of 1 plus square root of 1 plus square root of 1 plus x. So why this equation is recursive? So if we replace any of this big block with some variable y, then you will see that x equals square root of 1 plus y. And then if you think about this block, so y equals square root of 1 plus and replaces 1 plus x with another variable z, so you will see a similar structure of the equation. And finally, z equal square root of 1 plus x is already similar to previous two. Okay, let's describe this in more details. So if I take one block, square root of x, I can name it y. I can replace it with a variable y. So y equals square root of 1 plus x. So now I consider a bigger block like this, and I name this block z. So I will have z equals square root of 1 plus y. 1 plus y. Finally, I can take a largest block, which is x equals square root of 1 plus z. Because all those blocks are similar, so I can suspect that all variables x, y, and z are equal. So I can propose this idea, and then what happens? So I replace y with x, z with x, y with x, and z with x. And what I have, in all cases, I have the block x equal square root of 1 plus x. So let's try to solve such an equation, but for that I don't need to solve the big equation. I just need to solve the equation for the small block. Okay, let's solve it. So write x equals square root of 1 plus x. So how to solve this equation? So we square both parts, so it will be x squared equals 1 plus x. Then move all the terms into the left side. So I will have x squared minus x minus 1 equals 0. So this is standard quadratic equation, and we solve it in terms of, so we have a coefficient a, b, and c. So where a equal 1, b equals minus 1, c equals minus 1. So what we have, so x equals minus b plus minus square root of b squared minus 4ac, and we divide everything by 2a. So in this case, x equals 1 plus minus square root of 1 plus 4. So it means square root 5. So let me write final solution. Square root of 5 divided by 2. That's it, we solved it. On the next step, we need to check whether our solution is suitable for the equation. So therefore we need to analyze the equation again. So we have roots and the root must be positive. So it means that 1 plus x should be greater or equal 0. Another condition, okay, this condition works for all of them. And also second condition, the square root itself should be positive, so it means x should be greater or equal 0. So the second condition is what we need to consider, because 1 plus x would be automatically satisfied by the second condition. Okay, and then we have a solution, so x equals 1 plus square root of 5 over 2, and the second solution is x equals 1 minus square root 5 over 2. So the first solution is positive, so the condition is satisfied, so we consider it correct as a correct solution. But the second solution is negative, so greater than 0. Oh, not greater, smaller than 0. That means that this solution is not suitable. So it means that we have only one solution, one suitable solution. 1 plus square root of 5 over 2. So we solve our equation, but I'm wondering actually if if I have this solution x equal 1 plus square root 5 over 2 would be suitable for this equation, because it seems to be, I mean, if you substitute here x instead of x, 1 plus square root of 5 over 2, the equation looks crazy. So, but let's substitute and perform some rearrangements and figure out if when we substitute x, we get the same x in the output. Okay, let's start with the smallest block, square root of 1 plus 1 plus square root of 5 divided by 2. So how to rearrange this expression? So we need to find, first we need to find a common degenerator, so which is 2, and so it will be 2 plus 1 plus square root of 5 divided by 2. So it will be 3, and then we need to make construct a complete square. In order to calculate the square root, we need to construct a completed square. So what to do? For that we multiply both sides by 2, and what we have? Okay, we have so under the square root we have 6 plus 2 square root of 5, and here we have 4. So the denominator can be moved out of the square root. So, and in the square root we have 6 plus 2 square root of 5. And 6 can be represented as 1 square and square root of 5 squared to complete the square. So we can say 1 squared or square root of 5 or 1 squared, the way you want, and then square root of 5 squared plus 2 square root of 5. Then we have a complete square, which is forget about square root of 1. We just write 1 plus square root of 5 squared. Also need to put 1 over 2 and square root to calculate this expression. So I apply square root to square, so it will cancel, and I will have 1 plus square root of 5 over 2. So it means that after in this equation I will get my x. So now if I substitute that x to the next equation, I will get another x. I will get another x for this block, and finally I will have x for the final answer. So it means that our solution is correct. So how to consider such recursive equations? So you need to find a common pattern for each block and sub-block. So for instance, if you consider a big block, you replace it with x, and already you know that this is x. Okay, how to consider such equations? You need to find a common block. So if you consider the biggest block, so inside you have a sub-block with a square root, and this sub-block, if you replace with x, so would represent x plus square root of 1, and finally, so the equation will look similar, 1 plus, so if you replace again square root of 1 with x, so it will always look similar to this x plus square root of 1 plus x type equation. And if you see this pattern, you can apply this as a solution which I showed. I hope you like this video, and I hope this video will be useful. Thank you very much. See you next time.